the term waste. Waste is the term which is normally used when, but in simple words, waste is that thing which is not for our use, but if the thing is maybe used by other person. For example, if I have my old mobile, so it is waste for me, not it is a waste. So the definition of waste is changing with respect to if my mobile is totally out of use, if it is totally 10 years old or 15 years old, even though it is workable for anyone else, or so if any substance or anything lose its all uses, and it on the other side it do not have any economical benefit, then this substance is supposed to be waste. For example, if we are talking about, if we demolish a building, so there is a big material waste, a construction waste. Even though this is not a waste, this is a waste for the person who want to build another building. But this waste is not a waste for a person who want to fill a ditch part of the land. So if the thing lose its all functions and even and all economical values, then it was supposed to be a waste. Then hazard, risk. First, we want to understand that what is hazard and what is risk. Hazard is something with the potential to cause harm, and risk, the likelihood of harm occurring. What is the difference between these two things? The difference is very simple. If we are talking about an acid, so acid is hazardous. Yes. Why? Because it can cause harm. Acid is risky. Yes, acid, use of acid is risky because it can produce harm. But if we are talking about water, if we are talking about water, that is water hazardous? No, water is not hazardous. But water is risky? Yes, in some conditions, water is risky. If we are dealing with hot water, if we are dealing, if we are swimming into the water, so the conditions makes the water risky, but itself water is not hazardous. So this is the difference between hazardous and risky. Sometimes hazardous, non-hazardous things becomes risky. A control measure means a way to reduce risk. Every laboratory, every facility, academic laboratory or any other kind of laboratory, or chemistry laboratory, biological laboratory, any laboratory have its particular control measures, and we have to look into it later on, inshallah, in the same presentation. So the question arises that why do we need to be serious about chemicals? Yes, we need to be serious about chemicals. Chemicals, there are some, there is a general rule that every chemical is hazardous and every chemical can damage or can be lethal. How we can say that and why we want to know that? Because of the past experiences, we can say that chemicals are hazardous, and if you do not care about the chemicals, then it will be more lethal. Even they can cause a death. So here I want to show you one video. This video. This is yes. Let me reduce this sound. I don't know. Yes, this is the sound. This is a video which is this accident was happened in Texas in 2011, and this was a chemical factory. Here you can see the gauge of the fire, and almost everything was destroyed in it. This is the importance of chemicals, that if you do not take the chemicals seriously, and so it will cause harm, too much harm, on that scale that you cannot understand. So in order to produce some basic understanding about the seriousness of the chemicals, I played this video. So I think this much is enough. This is just to show you the seriousness of chemicals. So if you are in a chemical facility, so you have to know that in what suspected form of chemicals are there. Chemicals are in the laboratory or around you in these 6 forms. For example, dust, fumes, gas, mist, vapors, oxygen deficiency, and enrichment. Now we are talking individually about all of these things. Dust, it might be a simple dust in your home. It might be a dust in your AC, or if you are grinding any metal. For example, if I'm cutting so I was here, I was explaining that are the 6 suspected form of chemicals. One is the dust. Dust means the grinding part of any material. If you grind metal, marble, or any concrete items, the small particles is the dust, and usually it is found on the floor. Then fumes. Fumes basically, whenever you heat any substance, especially in the case of welding, so the material, even the metal, goes into the air. So these are known as fumes. Fumes is produced in liquid. In some liquids produce fumes. Sometimes the liquid with high density do not produce fumes, but it depends on the liquid. Usually all liquids produce fumes. Then gas, for example, if we have a cylinder at home, so this is a part of gas which we generally we have around us in our homes and in our facilities. Mist is a small a group of small droplets. For example, if we want to understand what is the mist, so when we spray the perfume, so the perfume inside the bottle is liquid, but when it comes out of the bottle, it is in form of mist, means small droplets. So next, vapors. Vapors is the form of vapors is a kind of droplets when liquid comes from liquid state of matter to air. I may explain my word in this way, that if a water H2O, molecule of water is H2O, and if it is in liquid form, it is known as water. When it comes into the gas phase, into air, it is known as vapor. So vapor are those particles which evaporates from the surface of liquid. Usually it is happening all the time, whether what the temperature is. Temperature may change the evaporation, or in other words, may change the speed of producing vapors, but vapor produced at any temperature, at room temperature or even less than room temperature. The last thing, oxygen deficiency and enrichment. This thing is very important to know, to understand that what is the oxygen deficiency and enrichment, because if we are working in such an environment where oxygen is less and we have to work there, so we have to take care about our oxygen level. And or if we are working in an environment where oxygen is very high and we are working with those chemicals which are flammable, so we have to be care about oxygen level, that because oxygen acts as an oxidizing agent, so it will help here, it will help flame to get big and big. Types or classification of chemical symbols are the lab, even though you have to know about these symbols. The first symbol is explosive. Explosive means both things, that whether this thing is explosive or whether it is explosive at any condition. For example, sometimes things explode at just a small flame, just with a strong hit, or just sometimes explosive explode because of some vibrations. So you have to take care about the explosive, and this symbol will show that this container, that container may contain the explosives. Then this is a symbol for flammable, means the container with this symbol have the liquid or have the things which are highly flammable. Flammable means they catch fire. They are willing to catch fire. Oxidizing agents, the example of flame is general example of flame is a gas, means in our home we are using the cylinder, so the gas inside the cylinder is a flammable gas, so it loves to catch fire. Oxidizing agent, oxidizing or oxidizers or oxidizing agent, these are not the flammables, these are not the explosives, but these are intermediate between them. They support flammables. Uh, for example, air. Air is an oxidizing agent, or it may act as oxidizing for the flame, because if there is no air, then the flame will go down or turn off. Gas under pressure. This is a symbol for gas under pressure. Whenever you have a cylinder, then there is a gas. There is no logic to have an empty cylinder in the lab. So if the cylinder is in the lab, it is supposed to be filled with the high pressure gas. And you have to take care about it, because if the cylinder explodes, it produces a lot of mess. Then corrosive. Corrosives are the chemicals which produce harm on your skin or on the surface or any kind of surface. Sometimes corrosive produce only effects on your skin. Skin is also surface. So sometimes corrosive for metal surface. It depends on the type of corrosive. Just corrosives. Then acute toxic. Acute toxic is almost all chemicals. If you inhale it or if you swallow it. So sorry, this for the sound. Uh, Acute toxic, usually all chemicals are acute toxic. They may produce harm or they may produce lethal health effects. Then harmful irritant or skin sensitizers. These are the chemicals which are not lethal, but they produce irritation or some bad effects or some bad marks on your skin. Like sometimes nitric acid produce when nitric acid react with, I think, the protein in the skin, then they cause yellow marks on the skin. On the other hand, hydrogen peroxide, if it gets in touch with your skin, it produces irritation on the skin. Then this is a symbol for carcinogenic. Carcinogenic are naturally those chemicals which can produce cancers. So any kind of cancer means it also depends on the quantity and the toxicity of the chemical. Hazardous for aquatic environment. Hazardous for aquatic environment is all generally all chemicals are the hazardous for aquatic environment, even water. Why? The question is why? Because sometimes once I was on a visit in steel industry, so there I saw a caution that temperature with a difference of 5 degrees centigrade means if the temperature of the lake is 30 degrees centigrade and fishes are living a good life at 30 degrees centigrade, and you throw back water into the lake with a difference of plus minus 5 degrees centigrade, that whether it is less than 25 or whether it is above 30 degrees centigrade, 35 degrees centigrade. So it can cause damage to the aquatic life, and because of this continuous damage, this marine life shifts to other areas where they have a suitable area for to live. So all the chemical, this was an episode which I'm talking about the water. So all chemicals acts in this way. Then here are some definitions. If you all students want to read these definitions, then they may read it because I discussed these definitions in the slides. So, but if you want to read these definitions, then this is the definition for corrosives. This is the definition for oxidizers. Then here are some examples. I don't want to read it again because we discussed it in previous slides where we were talking about corrosives, oxidizers, then flammable, then toxic chemicals. I'm here on this slide for a few seconds. If you want to read it, then you may read it. Then we will go to the next slide. Okay, so how chemicals can interact with humans? There are generally 3 ways of human interaction: ingestion, inhalation, and dermal exposure. Dermal exposure means contact with the skin, basically. So these are not only for the chemicals, but these are the 3 ways how human take the things inside their body. Some things, for example, air, we breathe air, it goes into our lungs. This is inhalation here in this first picture from right. And in second picture, if we eat anything, so it goes into our stomach. This is known as ingestion. Eat or drink, both goes into the stomach, so it is known as ingestion. The third thing, skin contact or dermal exposure in terms of chemical, in terms of scientific language, dermal exposure. Dermal exposure is, for example, if we are using some lotion, some cream, some oil on our skin. So this is a dermal exposure because dermal exposure is also a way to take molecules inside the body. So these are 3 ways. And unfortunately, chemicals can also go into the body in these 3 ways. Oxygen, we are inhaling oxygen. This is a gas, a chemical. So we are inhaling oxygen, and in the same way, we are inhaling all other gases. Ingestion, if we, it is not logical that if I say that someone drink acid or someone eat anything else, but if I'm taking the example of a salt, NaCl, the table salt, we all are eating salt every day. So again, this depends on the chemical, that is it toxic or not, is it harmful or not. So there is a wide range of chemicals. So we cannot put a single rule on all chemicals. There is a difference between sodium hydroxide and NaCl. There is a difference between acid and a water. We can drink water, but we cannot drink acid. We can drink, even we cannot drink concentrated acid, because sometimes like orange juices, they are also in acidic in nature, but it is very light. Similarly, we cannot eat sodium hydroxide, but we are eating sodium chloride, which is the table salt. So it depends on the salt. It depends on the chemical nature of the solid or liquid compound which we are taking in. The third thing is contact. As I told you, that if nitric acid touch your skin, it produces irritation because it goes into the skin and it reacts with the protein in the skin. So in this way, every chemical can interact or react with the human skin, which is known as dermal exposure. Now, it is for the lab, and it is also for the normal atmosphere. If you are feeling any of these symptoms, then it means you are exposed to the chemicals around you. Chemicals not only means that you may find the chemical in a bottle or in a big canister, but sometimes, for example, I think sulfur gas or sulfur dioxide, I think. If there is a drain, means from the drain from residential area or industrial area is going towards the disposal area. So that drain lines usually covers with some material or concrete material. So inside this back area where industrial effluent is going on, they produce sulfur dioxide gas. So sometimes you smell sulfur gas or rotten egg smell near the industrial area. It is because of the effluent dumps underground which are moving towards the disposal area. So if you feel any kind of symptoms like eye discomfort, breathing, difficulty in breathing, dizziness, headache, nausea, vomiting, skin irritation, so it means you are exposed to the chemicals in that area, and you are supposed to leave this area because this is not good for your health. Again, we are talking about the labs. So if you find any of these kind of symptoms within the lab, within your department or on the floor, then you have to tell the responsible person that there is something which makes you discomfort, which because of which you are feeling discomfort. So do not stay there, leave this area, because it's not good to be exposed to the chemicals. Now the question arises, if there are a lot of problems with the chemicals, then why we need to work with the chemicals? And if we are working with the chemicals, then how we can work with the chemicals? So there are basic rules. It is not that much difficult to work with the chemicals or deal with the chemicals. If once you get into the routine, it will be a part of your life. So if we follow these routines, if we follow these standard operating procedures, SOPs, then it will be easy and safe for us and safe for students to work in the lab. So there are a few things: application of the best practice for handling chemicals, for chemistry processes to minimize the risk. Yes, if you read the process and then you apply the process, then it is a perfect way. If, for example, there is a process that if you want to dilute the acid, then you will pour acid into the water. You may find it in any book. But if you do vice versa, means if you put water into the acid, then it will be harmful. It will be a risk. Why? This needs a bit chemistry, but I try to explain in few words that if you put if you put acid into the water, this is the right way. And if you, because when acid comes into the water, it is an exothermic reaction and it will increase the temperature of water. But on the other hand, so water get warm. On the other hand, if you put water into the acid, same exothermic reaction, but at that time, in this way, a lot exothermic reaction with very high speed. So water boils and jump out of the acid. So it may affect you if it touches your screen. It may produce burn signs on your screen. So if you follow the written procedures or the SOPs inside the lab, then there is no harm in the lab. It is a normal area. Do not eat, drink, or smoke into the lab, because in labs there are sometimes, even we are taking a lot of care for the procedures, but sometimes there are some acid marks on the surface, on the floor of on the shelves in the lab. So if you are eating or drinking, so it is more chances that sometimes chemical will attach with your food, so it will disturb you, either your skin or your inside. Personal protective equipment, as in this picture, he wears gloves, goggles, lab coat, shoes. It also depends on the nature of work. Whenever you are dealing with the flame or with the acids, with the bases, you have to wear the glasses, and always wear the gloves, always wear the lab coat. It is for your protection. Store chemicals properly. You have to store the chemicals properly at a particular area in the lab. In your lab, you have to specify the area for the flammables, for oxidizers. Never put oxidizing agents, oxidizers with the flammable. Never put acids with the flammables. So every chemical have its own proper particular area in the lab, and you have to designate it. Then, okay, now how a new person in the lab may know about the chemical inside a container, that what chemicals is inside the bottle, what chemical is inside the container. So every company, this is an international standard, that every company put this mark on the bottle or on the container. Okay, I'm using the word container, not the bottle, because container might be a bottle. It may be used for liquids, for solids. So every container have this or this kind of mark on outside the container, from where we can find what we can find: the product name, its abilities. For example, here we have 3 signs. One is corrosive, other is toxic, the third one is flammable. So by this picture, at first glance, we comes to know that ammonia, because its name is ammonia, ammonia is corrosive in nature Ammonia is toxic in nature. Ammonia is flammable. So we have to work with ammonia on the bench in the portion of lab which is away from the flame, because ammonia is flammable, it can catch flame. We have to wear goggles, and if the mask is available, we have to wear mask because ammonia is toxic. The third thing is corrosive, means ammonia can affect our skin, so we will wear gloves and the lab coats. So this tag on the container may explain you everything. Then it may explain you in few lines. It gives you also some information that if you have this chemical, if you deal in some wrong way, so what you will do in initial step, because the ultimate step is to take the person to the doctor. But before this, you can drink a lot of water, you can drink milk, or you can drink all other kind of basic materials. But the best way is to take the person and run towards the hospital or towards the doctor. Okay, it is another general rule in the lab. As in previous slide, we have a general rule that do not eat, drink, or smoke in the lab. This is another general rule, that never smell or taste a chemical to identify it. If there is a caption or tag over the container, then read it. If there is no tag, then leave it. Do not try to find that what chemical is inside by using your nose or by using your tongue, even by using your hand. Just read it. Do not never try to smell it or taste it. For example, if you smell carbon tetrachloride, which is also not the carbon tetrachloride, uh, trichloro trichloromethane is a compound which is organic molecule, which is also known as I forget its name. Its name is chloroform, basically. Yes. If you smell chloroform, then you will senseless. You may not stand on your feet. Third thing, separate the expired chemicals. Then means in lab, you may have a lot of expired chemicals. So you have to separate it with the chemicals which are in use. In next few slides, we will come to know, or we will discuss it, what the expired means. Chemical is a chemical. So what expired means, we will discuss a few minutes about it later on. Another very important thing, that is why I made a separate slide for it, is SDS, or data safety sheets, data safety sheets. Okay. Every chemical, it is duty of the lab in charge to tell you, or the best way is to give you or put the sheets with the chemicals, that this chemical, that what is the maximum hazard of this chemical, and what is the toxicity of this chemical, and especially for the chemicals which are not normally used. For example, if I am the lab in charge and I am dealing with the first year students in chemistry department or in engineering facility, so I may explain them everything. I have to provide safety data sheet for every chemical, especially about the acids and the organics. But if they are the students of masters or the PhD, so it is not ideal to tell them that acids are hazardous and organics are hazardous. Be careful about these things. These things have to be understood also have to be understood by the students or by the juniors as well. But on the other side is a duty of the lab in charge to produce data sheets, safety data sheets along with the chemicals, so it will be easy for the students or the trainees to come into the lab and find that and find to work with chemicals as per their toxicities. This is the example of data sheets. Here we can specify that what is the health category of this. Means it is in first standard, second standard, or third standard, or fourth standard of the health. Means, for example, first, I will tell you in next stage. Health hazard, fire hazard, specific hazard, or instability. Everything have 4 stages. For example, if I'm talking about sulfuric acid, then sulfuric acid health hazard is maximum. Okay, so I will put 4. Fire hazard, it can produce fire, so is 3 or 2. Instability, it is stable, 1. Specific hazard, yes, specific hazard, it is a very much concentrated acid. If I'm talking about concentrated sulfuric acid, then it is again 4. If I'm talking about less concentrated, then I might put 1 or 2. And on the left, there is a detail. This is a detail detail safety data sheet. It should be placed with all chemicals, especially the chemicals which are new to that level which is working in the lab. That level means level of what level you are supposed to have with the students. For example, if a first year student, then I understand that they do not know anything. If second grade students, if second year student, they know something. Third year student, fourth year student, PhD student, they have to know many things. So these safety data sheets are for the first year students, second year students, or the new persons. All the educated students, means master's degree, graduation, complete graduation degree, and PhD degrees, they are supposed to know these things by heart if they are working in the chemistry labs. Then few more definitions which we will use in next slides. Expiry of chemicals. Expiry of chemical is a second stage. If I want to give, if I explain you with one example, then it will be easy for you to understand that what expiry means. Expiry means you purchase milk from any shop. So there is an expiry date. It is written as consumed before, CB, consumed before this date. So you have to consume this milk before its expiry date, because after expiry, this company is not responsible that whether it is in good condition or whether not, whether it will be a milk or it will be something else. Because we know that if we put milk for, if the expiry date is for 2 days and we put it for 4 days outside or outside the refrigerator, then it will not be a milk. So there is an expiry of everything, even for humans. So, but humans do not have expiry date, but they are supposed to be expired after a certain time. So chemicals are also chemicals also have the expiry dates. What expiry of chemical means? Will they become something else? Yes, it is possible, but after expiry date, potency or the concentration. Potency is the exact word, but then I was talking about expiry. Yes. So expiry of chemical is related with the concentration. It is written as it is 1 molar or 2 molar. Let's say 1 molar. So after expiry, and they usually give an expiry of a year. So after expiry date, it is not ideal that the acid inside the container is 1 molar. The concentration of the chemical change after expiry date. So that is why we have to be specific with the expiry date of the chemicals, that we have to use the chemicals before its expiry date, because after expiry date, maybe these chemicals will not give you the promising results. Expiry of the chemicals depends on 3 things: chemical stability, transpiration loss, and human factor. Human factor may disturb the expiry anytime. For example, if you bring, again, if it is an example of milk, if you bring a milk from the shop and you by mistake you put some salt into the milk, or if you put some drops of lemon into the milk, then it expired even in the first day, even in the first hour. So human factor is a different thing. The other 2 factors, chemical stability and transpiration loss, these are the 2 factors which are normally are time dependent. That is why every company gave the expiry date of chemicals. I hope you understand. Shelf life. Shelf life of a chemical or anything. Shelf life means if you didn't open the packaging or didn't open the bottle, it is sealed back as it was received from the supplier, and you put it in your store, then how much time you may take it in your store and do not use it. Normally, all chemicals have 2-year shelf life before opening. After opening, shelf life convert into expiry. I hope you get my point. That if there is a chemical which you didn't open, you may put it in your lab or in your store for 2 years. But if you open the chemical, then this shelf life start into expiry. Then you have to see the expiry date, that whether it is expiry date of 6 months or whether this is expiry date of 1 year. It depends on company, and it depends on concentration, accuracy of the chemical, and the concentration of the chemicals, and also the nature of the chemicals. Because sometimes if the chemicals are hygroscopic in nature, hygroscopic means they absorb water molecules, so you have to always you have to keep tight its container. But if once there is a leak, or there is you forget to put the cap on it, so it may absorb a lot of moisture from the surrounding, so the expiry comes soon. So this is the difference between shelf life and expiry of the chemicals. Then disposal and treatment. Disposal, first you try to save the material, purchase least material or low volumes, and then you will try to use it. And if you cannot use it, and they are supposed to be expired, then you try to recycle. If they cannot recycle, then the last stage is disposal. Disposal means on-site or off-site, means within the lab or outside the lab. In our chemistry terms, on-site and off-site means outside, inside the lab or outside the labs. Placement or treatment of waste. I must know how I dispose the chemicals into the lab. Every chemistry person or every student who is going to be a chemist must know that how they are supposed to dispose the chemicals within the lab. They must put the separate bins. That this is a separate bin for chemicals, this is a separate bin for papers, this is for glass, this is for metals. Everything should have a separate containers. This is the disposal of the chemicals within the lab. And outside the lab, there you have to go for other companies. Generally, universities do not have the facilities to dispose the chemicals. There are some other companies who are this particular facilities. Treatment of waste. Treatment of waste means the way to make them less hazardous. Sometimes you can make the waste non-hazardous, but in some cases you can make it less hazardous, but you cannot make it non-hazardous. This way to make the waste less hazardous or non-hazardous is known as treatment. And the way to manage the waste inside the lab, manage in this way that it will not produce harm to the lab or any person. This is not the manage that you throw everything into the same container. For example, if you have a plastic basket in your lab, you throw glass into the same container, then you throw papers into the dustbin, then you throw acid into the dustbin, then you throw something else, then you throw something else. And unfortunately, you will throw your lighter. So sometimes you will see a fire in the dustbin. So this is not the disposal. This is a very bad example of disposal. Disposal inside the lab means you have to dispose. We will discuss it in our presentation somewhat later on, maybe after 2 or 3 slides, inshallah. Or in your faculty that where basically ideally laboratory is supposed to be that area where eligible persons means technical persons. Academics, technical persons use least quantity, not low, the least quantity of chemicals, and they produce some results. If the results are good, then they will produce on big scale, means they will use more chemicals. That is why in industrial terminology, there are 2 stages. There are 2 scales. One is lab scale and one is commercial scale. Lab scale means use least amount of chemicals, react them, get the product. If the product is useful and if you get a good results, then you will give it to the laboratory for, you will give it to the industry for the industrial scale. Industrial scale means on big scales. So generally laboratories are supposed to use least chemicals. Why I'm emphasizing on least chemicals? Because if you do 10 reactions 10 new reactions in your lab a day, so 10 new reactions in your lab a day. So sometimes all these 10 reactions are useless. So the result of useless product is to throw out into the respective dustbin or into the respective container. So that is why we use least chemicals to produce least waste. If we run these reactions directly onto the industrial scale, then it will produce a lot of waste. So that is why definition of laboratory is important to understand. Okay, now we are in the laboratory and we are working with the chemicals and reactions, and we have the products. Now we are going to talk about the laboratory waste management and disposal. So the best way before disposal, I'm talking about before disposal, waste management. The best way of chemical is to retreat or recycle. Retreat or recycle means if, for example, if I use acid or if my acid expire, so can I get it back into the same concentration? For example, if it was 1 molar acid and after expiry date, it becomes 0.5 molar or 0.25 molar. So can I get back get back into the same concentration? Treatment or recycling of chemicals, not 100% chemicals, most of the chemicals is possible, but I'm talking about the recycling of the chemicals, that there are some external agencies or external companies which are expert in recycling and treatment, and they have a proper facility for it, for the treatment and recycling of the chemicals. So this is a good way, this is a good practice that you may give these to recycle or treat the chemicals. Chemical waste includes solid, liquid, and gas. Aggregate them. We need different separate containers in the lab because, as we know, that chemical waste sometimes solid, sometimes liquid, and sometimes gases. We cannot capture the gases other than we have an proper exhaust system in the lab and with some proper scrubbers inside the exhaust, which are not used. So if we have a scrubber system in the exhaust, so we can capture the gases as well. But in a simple way, we are talking about so as we know that chemical are toxic, corrosive, many things is possible. So we have to put them in different containers. This is a part of lab management, that these use separate containers or separate canisters for all them. Glass waste, glass disposal, glass waste. There's a lot of glass waste in the lab because you are using glass beakers, glass cylinders, glass pipettes. Everything is made up of glass. So that is why this is supposed to have a big garbage portion of glass. So you have to use separate disposal boxes for the glass. Then you have separate disposal canisters for the liquid chemicals and solid chemicals. Do not mix the chemicals of different natures and of the same nature. What it means, let me explain. Number one, avoid mixing of chemicals in dumps. What it means. If you mixing solid with liquid, then forget about recycling of the chemicals. No one can recycle. If you combine two different acids, for example, sulfuric acid and nitric acid, then you cannot separate or recycle them. If you combine two solids, even though it will be very difficult for any agency to separate it, any expert to separate it. So every chemical have its separate dustbin or a separate canister to put in. The best way is to use the same bottle. For example, if you purchase an acid a year before and you use the whole acid, so this bottle is empty, do not throw it out. You may use this empty bottle for the waste of any other chemical or the same chemical. So use these bottles for chemicals. Do not mix them. Either not the mixing of solid to solid, do not mixing the liquid to liquid, even do not mixing same kind of chemicals, means acid to acid. If these are different acids, do not mix them. If they are different organic compounds, do not mix them. Otherwise, recycling is not possible of mixture. Laboratory must maintain labels. Yes. After disposing, no, not after disposing, after giving a separate canister to a chemical, label it. For example, maybe you are using old bottle of sulfuric acid, but this time you want to put organic compound like methanol in this bottle. So you wash it, dry it, and then put the methanol in water. So you have to put a new label, because old label said that this liquid is sulfuric acid, but you know that you put methanol in it. So you have to put a proper label on every container. Either it is for solid or liquid, you have to put a separate. Otherwise, they will mix it and it will again a big problem. Do not mix incompatible chemicals. Incompatible chemicals, sometimes one is flammable and one is oxidizer. If you combine these chemicals, then result will be a fire or result will be a very bad for the lab, this result. Okay, when you pour liquid into the bottles or the canisters, keep in mind to at least 2-inch empty headspace, because as we discussed before, every liquid evaporates at every temperature. Temperature may increase or decrease the rate of evaporation, but evaporation is going on at every temperature. Is it clear? So if you, for example, you bring petrol from or benzene from the benzene station at home and you put it in a glass, you see that this will run away, this will evaporate. So you have to put the chemical in a container and at least 2-inch headspace empty before, because this empty space is for the vapor portion. If you fill it completely till the mouth of the bottle and then you close it, so there is a chances that if room temperature is okay, so at high temperature it may explode or it may blast. So you have to put a space empty over the chemical in a canister. It is for liquid and it is also for solid chemicals, because there are some chemicals which directly convert into the vapors from solid state. Means if you put the chemicals in a tray, then after some time you will see that there will be no chemical. So they will convert into vapor directly from the containers. So you have to leave empty space even for the solid chemicals. Okay. Handling hazardous waste material needs proper training. Yes, like in this picture, this person have a proper training. He wears shoes, he wear proper dress, glasses, and cap, and he is working with a register to make the data sheets, and he's making these chemicals ready for the company to take it for the disposal. Okay, it is another general rule for the lab, and it is very important rule. Do not throw, because it is usually a practice in all labs that we throw the chemicals into the drains. So it is a very bad habit, and it is a very bad practice for the lab and for the environment that you throw even a dilute chemical into the drain. You can throw a very dilute chemical, because after some experience in the lab, you comes to know that how much concentration of the chemicals you can throw to the drain, or what concentrations you cannot throw into the drain, because the end of drain is the groundwater or the seawater. So both will be affected because of these concentrated chemicals. So it's good to make it habit that do not throw the concentrated or moderate chemicals into the drain. Again, use compatible containers for the chemicals, because if you use non-compatible containers, if you want to throw concentrated sulfuric acid which is expired and you use a plastic bottle, then acid comes out. If you used a metal container, then acid will disturb. After some time it will corrode and acid will come out. So you have to use glass. Means every container you have to know or read about the compatibility of the chemical and the compatibility of the container. It is valid for both liquid and solid chemicals. Containers must be labeled, because if there is not a particular new label on the container, then it means you are guiding a wrong thing to the person, because blank container means blank means it is not on. You feel that it means it shows that you are not responsible for this chemicals. It usually sometimes it happens in the lab that, for example, I forget that what I want to throw, whether it is an organic chemical or it is an inorganic chemical. So I put it into the container and leave it blank. Means I forget, maybe other person have the ability to know that what is inside the container. But the mistake is to guide in a wrong direction. Means if you put acid and put a label of organic material, it shows that you are not serious about the work. Memory problem is normal with human. So if you forget, then leave it without label, or put the label that I don't know what is in it. In any other way, in any other words also possible. Okay, containers should be placed in appropriate waste bin. What it means, it is a same kind. For example, if I have 100 milligram of this chemical, 100 milligram of this chemical, 100 milligram of this chemicals, 100 ml of this chemicals. So I have all different chemicals in all different small containers. Later on, like in this picture, I hope you can see my cursor. In this picture, this person who is wearing yellow dress, he is putting chemicals in small containers into a big container. So this is also a technical thing. You cannot put different means reactive chemicals together. For example, you cannot put corrosives with flammables. You cannot put flammables with oxidizers, because the vapors, when the vapors comes out, they react and the big waste bin explode, or sometimes the toxic gas produced inside it. So even though you have to take care about this packing of small containers into a big container. Another slide. This is an example of the label which you are supposed to put on the glass. You can make it your own, anyone can make it own, but the basic things should be there, that from which lab it comes, who is the responsible first person, what is the quantity, what is the percentage concentration, what is the chemical inside it, So there are three chemicals: methanol, chloroform, and toluene. Okay, the nature is toxic and flammable. So it means this label was put on the big canister. Big canister means inside this canister there are three small bottles. One is of methanol, one is chloroform, and one is toluene. They do not mix with each other in the same bottle. They put these organic chemicals in different bottles, and then these different three bottles put into a big canister. Why they put these chemicals together? Because the nature is same. They all are flammable, they all are toxic. So they cannot interact with each other. If you put one wrong chemical in the same canister, then it will be a wrong decision. Okay, now this is a point about gas cylinders. So if you are using gas, generally we are using sometimes gas in our lab for instruments, for some other purpose. If you have a gas in your cylinder, if you have a gas cylinder in your lab, so there's only two places for the gas cylinder. If the gas cylinder is filled and in use, then put it into the lab at a particular position. Do not put into the lab near the flame, near the flammable, or near the oxidizers. Put it outside the lab in a separate portion, in a specific portion. But if the cylinder goes empty, then return it to the supplier and replace with a filled cylinder like we use here in at our homes. So empty cylinder is not supposed to be placed in the lab. It must return to the supplier, because treatment and of cylinder is very expensive. If you are not using it, then any other person can use it, or any other lab can use it. Okay. Now those above all slides were related to the waste management. Now, when you manage the waste in small bottles, and then small bottles or small canisters into a big canisters, label it, then now you will call to the company who is responsible to take your disposal, means disposal from a lab. They will take it to their facility, they will treat it, or they will recycle it, or the thing which cannot be treated, or after recycling the part which cannot be further recycled or treated, they will put or dispose it into the specific facility. Means at the end it will go back to the environment. This is a long debate that is there a proper treatment or not. So I don't want to go into it, because our topic is the disposal inside the lab. Okay, before disposal, before giving it to the company, this is your responsibility, means lab person's responsibility, or the generator responsibility, means the person or the group who generate this chemical waste. This is the responsibility of this group, that incompatible chemicals are not stored in the same container. As I gave you the example, that all methanol, toluene, and or chloroform placed in a same container, because they all are the same chemical, or they all are compatible chemicals. They do not put incompatible chemicals into the container, because the reasons are here. As I discussed it before, because acid reactive compounds, if you put acid reactive compounds and inorganic acids together, they produce gases. If you put organic acids with inorganic acids, inorganic acids are flammable. Organic acids are flammable, inorganic acids are oxidizers or corrosives, they can catch fire. Water reactive materials, for example, I hope you saw in your labs that there is sodium in metal form. When you have a sodium in metal form, not in compound form, in particular atomic metal form, if you throw sodium into the water, it will catch fire because of highly exothermic reaction, and rate of exothermic is very high. So that is why it catch fire. So that is why you cannot store sodium near to the water, because unfortunately if they mix, they create a big fire. Oxidizers, you cannot put oxidizers with organic materials. Again, organic materials are flammable, and oxidizers are those chemicals which support the flame. So these both will cause a big damage. In Saudi Arabia, here in Saudi Arabia, this is SAPCO, our responsible company, one of the responsible company inside the Saudi Arabia, which can take your dispose from your lab. And also when you ask them to take your dispose, they ask you to, for the same guidelines, to put all chemicals separate, to all compatible chemicals into a same container, and then they will come check, and then they will take your disposed waste, and then they will take it to their facility. There they will treat it, and there they will recycle some chemicals, whatever is possible. And in last, on their website, they show that they shipped it to some other areas. So it is not good to send chemicals to the disposal lands. Okay, now our presentation is almost complete, but I want you to all give some advice to all students. Number one, reduce waste at its source. So you are the source, means I'm the source, means the lab is the source for chemical waste. So if it is possible for you to reduce the waste at its source, then it is an excellent practice. Here in this figure, that is green or blue, reduce, reuse, recycle, recovery, treat, and dispose. What dispose means the end. End means to throw out. Throw out means to throw out in a big garbage area. So it is not a good practice. Anything, first try to purchase chemicals as per your requirement. If you do not have a plan to use acid, so do not purchase acid. If you do not have a plan to use organics, do not purchase organics. So purchase with respect to your demand. So it means reduce the supply or reduce the junk. Reuse. If there is some ability to reuse the chemicals, then you can reuse it. For example, if I have an acid and I know that I can reuse the product, so I can reuse the product. It is not compulsory to purchase this product as a new chemical. Recycle, as I told you, that sometimes there are facilities to recycle the chemicals, because only for those chemicals which are using in bulks. So if you have a recycling ability, then recycle. If there is chance to recover, then recover. If there is chance to treat, even in the lab or even in the expert facility, then treat it with other chemicals, or the end product is dispose. Dispose means the garbage we are giving to our next generations. In second last slide, I want to show you these garbage areas which are created by our elders or us. What we are creating these garbage areas. In this picture where you see 4 or 5 trucks, this is a garbage dump in China. This is like a mountain. And this, and the other picture, this is garbage dump in Africa. So the best practice is to reduce, reuse, and recycle. Otherwise, our elders give us 2 or 3 or 200 or 300 garbage dumps, and the speed with which we are consuming the world resources to our generations, we will give them almost half of the world as a garbage dumps, because 70% of the earth is already of water. So remaining 30%, we are living. We need agriculture, and we need garbage dumps, and we cannot live near the garbage dumps. So keep in mind that our future is in our hands, whether we want to have a healthy life or whether we want to give a life full of diseases to our next generations. Thank you. Any question? I have a video for you related to some these lab practices, but I will send it to Dr. Fahad, so he will share it with you, because if I play it now, it will take more 13 minutes. So it's up to you whether you want to play it now or whether you want to have it from Dr. Fahad. From my side, it's over. Please, questions.
Okay, thank you, Dr. Jeihan, for valuable information that give us in this workshop. I think it's better to just Dr. Jeihan send it to me, the video, and I will share it with the student in WhatsApp group.
Sure.
Okay, and now the question times. If you have any question, you can open the mic and ask Dr. Jeihan, or you can ask through the chat. Okay. You have any question? Okay, Dr. Muhammad Abid. Okay. Okay. You have any question? And so, let's see. Okay. So there is no any questions. Finally, we again thanks Dr. Dr. Jeihan for this information, and we want to give you this certificate to thanks Dr. Jeihan for your times.
Thank you. So nice. So nice.
Okay, and I will send it to you, inshallah, as a
inshallah.
PDF, inshallah.
Sure, sure. My pleasure. It will be my pleasure.
Thank you, Dr. Jeihan.
Thank you. So nice of you. Jazakallah khair.
Me too.
Assalamu alaikum.
Salam. طيب، في أسئلة يا شباب قبل نقفل؟ طيب محمد الزهراني. طيب محمد، نحاول ناخذ العرض من الدكتور جيهان ونرسله لكم ان شاء الله. طبعا موضوع الاسئله وموضوع السؤال حق التقرير برضه حنسال الدكتور جيهان فيه، وحنبلغكم فيه برضه على الجروب ان شاء الله. الشباب الموجودين معانا من الخريجين بس ارسل اسمك الثلاثي على رقم جوالي بس على اساس موضوع الشهاده. في استفسارات اخرى شباب؟ طيب إذا ما في أي أسئلة نشوفكم إن شاء الله المحاضرة القادمة اليوم إيش؟ طيب نشوفكم الأحد القادم شباب البيئة إن شاء الله. صلى الله وسلم على نبينا محمد وعلى آله وصحبه أجمعين.